Hello and welcome to the third episode of our GODS Showcase series. In the previous episode, we explored how we can use the on-value changed events of our observable variables to easily react to changes in data. We used these events to update a health slider in our UI to display the current health of our player. Also, we added 3 types of currency to our game which the player can collect. Like the health slider, the currency amount gets displayed in the UI and only gets updated when necessary. Now in this episode, we will implement a checkpoint system with a custom event. When the player reaches a checkpoint, we will make use of the data within our observable variables to save our data to a save file using the GODS SaveSlot system. And looking forward, in the next episode, we will then use the SaveSlot system again to load in the saved data to then update our scene accordingly. Between the last episode and this one, I have done some cleanup, and I prepared the project for this session. First, I replaced the coin text component on our currency text in the UI with a GODS Bind Text Mesh Pro component, as this handles updating the text the same as the coin text script we created in the last episode. Then, I also removed the health slider component as we are using a GODS Bind slider component now instead. Second, to keep this video short, I already prepared a checkpoint prefab with a basic checkpoint script. Then, I increased the size of the level a bit and added some more collectibles which we can pick up during our run. Third, I created a SaveSlot handler script which we will use to save and load data at fitting points in our game. Finally, I also created a script named Savable Object List. We can attach this script to our collectible coins and diamonds to store their position in a list. Later, we can use this list to save the positions to our hard drive. Let's start with the checkpoint script. This script is quite simple. It has a Boolean flag which is false, and when the player reaches this checkpoint, we set the flag to true and activate some particles. We also fire a static event called checkpoint reached event, which allows us to inform other objects that a checkpoint has been reached. Next, let's have a look at the SaveSlot handler class. It references a GODS SaveSlot, which will be used to save and load data. In the start method, this class subscribes to the static event of our checkpoints, and when the event gets raised, it creates a new autosave file. We will have a look at the third new script later in the video. Let's first test our game in its current state. The scene currently has a few checkpoints in it, and it also has GameObject with a SaveSlot handler script attached. When I start the game and move to the right, I can collect some coins, and when I touch this pole, the checkpoint gets triggered, and it raises the checkpoint event. We can also see that the SaveSlot handler reacted to this event by logging saved data in the console. Nice. Now, instead of using a static Unity event to notify our objects that the player has reached a checkpoint, I will demonstrate an alternative method provided by GODS. Like with our variables, we can use observable game events, which are also scriptable objects, to react to events. The advantage is that we don't need to code as much. So let's open the SaveSlot handler again and remove the start and the destroy method. Then in the scene hierarchy, select the object and add a void game event listener to it. This component requires a raising event. Currently, we don't have such an event, but we can add one like with our variables and lists by clicking the Create button in the inspector. Let's rename this to something like checkpoint event and put it into a new game events folder. Then add an entry to the response event. Drag in the SaveSlot handler and select the save data method to be fired when the event gets raised. Note there are also other types of listeners like float listener, transform listener, vector 3 listener, and many more. You can also create this easily through a custom script creation window. These other game events can carry a value with the event, but for this example, we only need to know that a checkpoint has been reached and not where or when. Okay, now for the checkpoint script. Let's remove the static event and replace it with a void game event. Then in the trigger method, we write checkpoint reached event.raise and set the parameter to null as we don't need any. Then compile. We already created our game event, so let's open the checkpoint in prefab mode and drag in that game event. After that, this game event will be raised when a checkpoint is reached, and our SaveSlot handler will call the save data method. Let's test this. A nice thing about these game events is that we can test these events easily without having to move our player object to a checkpoint. We can just select the game event in the project window and click the Raise Event button. When I do this, the SaveSlot manager should write saved data into the console. Just like that? Perfect. As our event system works now, let's start saving some data to our disk. For this, we need to create a new GODS SaveSlot. Again, we can click the Create button in the inspector of the SaveSlot handler to create one. Let's rename it to Example Save 1. Before we add the data which we want to save, let's prepare the SaveSlot a little. First, we need a string value for the folder in which we want to save the file. We could use an observable variable of type string for this, and doing so would allow us to change the output file path at runtime quite easily, but for this example, we don't need a variable for this. Instead, we can just click that down arrow in the inspector next to the Create Variable button and select Use Constant instead. Now this field functions like a usual string field. For simplicity, I just enter Example Folder into this field. Next, we have a field for a username. We can use different usernames to support save files for multiple users. Also, if we had multiple users, using an observable variable for our users would make sense as we could use the same variable for other use cases, like displaying the user's name. In this case, however, I also just use a constant value and call it example user. Then we have more options like encrypting the file using an encryption key, and we can also add a screenshot to the save file. In this example, though, we won't make use of either one. Next, we can choose to limit the number of save files a user can create. We can distinguish between autosaves and manual saves. In this case, I only want to have a single autosave, to reset the player back to the last checkpoint whenever he dies during a level. Great, and now we can start adding data we want to save with this save slot. Let's start by saving the player's health and the amount of collected coins, diamonds, and emeralds. For this, we just add entries to the entries list and reference our observable variables. We also must give these entries unique names. When interacting with them in the inspector, the custom inspector will make sure these entries are all unique, so we don't have to worry too much here. Let's test this. When we enter play mode and start taking damage and collecting our currencies, these values get stored in our observable variables. Currently, we store the player's health and the number of coins, diamonds, and emeralds we collect. When I touch a checkpoint, our save slot handler creates a new autosave for us. We can find this save file quickly by selecting the save slot in our project window and then clicking on Open Save Folder. And here we see that a JSON file with our data has been created. Let's open it up and have a look at it. As we have not used any encryption, we can see our saved data in plain text, and we can see which values got stored for our health and our currencies. Nice. Now it is time to store more data of our game state into our save file. When we load a save file, we want to restore the game to how it was when the player reached a checkpoint. So in order to do that, we need to save the following data in addition to what we are currently storing: the player position or a fitting position at the checkpoint, the position of the remaining currency objects, coins, diamonds, and emeralds. And since we have more and less valuable collectibles, we also need to store positions of the big coins and the big diamonds as well. Note, we do not intend to reload the scene when we load a save file, but if we did, we also would have to remember which checkpoints already got activated, as the checkpoints in their current state can only be activated once. Okay, with that in mind, let's start with the player position by adding a vector3 reference to the checkpoint script. When the player triggers the checkpoint, we will store the position of the checkpoint itself into the observable variable. Next, let's go for the positions of our collectibles. As I mentioned earlier in the video, I have already created a savable object list script which can manage this data for us. It has a reference to an observable vector3 list for the positions, and it also has a reference to a game object list in which we store all the collectibles of a type at runtime. This game object list will later be used when loading a save file. This list will not be used for saving, as we cannot save game objects as they are. Instead, we need to save their position, rotation, and scale if we need to. For our case, storing the position is enough. So let's open the collectible coin in prefab mode and add the savable object list script to the game object. Then we need to create the observable lists for the position and for the spawned objects and name them properly, like coins positions and coins objects. After that, we need to do the same procedure for our big coins, our diamonds and big diamonds, and our emeralds. Let me fast forward the video while I quickly add the savable object list script and the observable lists to these prefabs. All right, let's open our save slot and add this data to be saved along with our health and currency values. First, we add the player position and then 5 more entries for our coins: big coins, diamonds, big diamonds, and emeralds. And don't forget to give these entries suitable names. This will allow us to debug errors more easily should we face some. Great, let's test saving our data by entering play mode. Let me just grab a few coins and diamonds, and let's also take a little bit of damage. And then I want to trigger a checkpoint to create a save file. Let's have a look at the save file we created. Nice, all our data is in there and ready to be loaded again. In our next episode, we will learn how we can restructure our scene with the loaded data from our save file. The references to our globally observable data structures like variables and lists make updating the visuals to reflect the loaded data quite easy. So don't miss out on the next episode, which will complete this showcase series for now.